Welcome to video 5 of the weighted least squares video series. As we saw in video 4, we concluded that we have non-constant variances of error terms, thus requiring a weighted least squares regression approach. In this video, we'll be covering quite a few of the same techniques as discussed in videos 2 and 3, but on the larger data set. To begin the process, we need to calculate the absolute value of our residuals so that we can apply those values to our weights. In running these two lines of code, we're able to calculate those absolute values. Now that has been completed, we can now calculate the weights by taking 1 over the absolute value of the residual squared. For demonstration purposes, here's that complete list, which we then plug into a new linear model with the code updated so that we have weights equal to our home fit weights. Having completed the model, let's take a look at the summary output. As we see down here, we have some consistencies in what we ran previously without the weighted least squares. Specifically, our intercepts and beta 1s are close, but slightly lower now that we've added the weighted least squares. In this model, the average home price for an average square foot home is approximately $276,000. And the beta 1 indicating how much the home price will increase for every 1 unit of square footage is now approximately $15,000 for every 100 square feet. I think it's of value to compare the two to make sure that we've actually captured the difference by completing the weighted least squares. As you can see in this chart, the blue line indicating our new model and thus clearly different than the one we had before. Before ending, we should check our results to make sure that we have corrected for the non-constant variances that we illustrated in video 4. Running the pair function, I'm able to compare the two plots of the residuals to see that we have made that correction. On the left, you'll see the model without the weighted least squares, and this is what we discussed in videos 2 and 3, and what we demonstrated earlier in video 4 is that we have a megaphone shape, thus requiring weighted least squares, which is the model on the right, and clearly we've seen we've corrected for that. That concludes the application of the weighted least squares model on the large data set. The next video will be a brief summary along with some advantages, disadvantages, and recommendations for when you complete your weighted least squares model.